we're going to continue doing problems on Grignard reactions. Let's do another synthesis. How do we plan the synthesis of the following alcohol? And here we have this. So that's my target molecule. And here we see that this is a secondary alcohol. So what we need is we can break two ways. We're going to do retrosynthetic analysis, disconnection approach. So let's break this into two fragments. I'm going to break here. And the fragment, I need one fragment that will have the oxygen, and that fragment will be an aldehyde. Remember again that Grignard reactions, when we do that with an aldehyde, you will get a secondary alcohol. So now that alcohol is secondary. When I break that, my fragment that contains the oxygen will be the aldehyde. So I have that. That came out really not that nice. Okay, that's an aldehyde, and then the other part, so this fragment here I need to make a Grignard with that, and that needs to have 3 carbons, but the bond with magnesium is here. And that, if I need to make that Grignard, I want to make it, so the arrow backwards, I want to make it with the corresponding alkyl halide, and that is magnesium and dry ether. So this is thinking backwards. So I should have drawn the arrow. So when you disconnect, this is the disconnection, which means that the reaction that we want is between the aldehyde that is shown here. This is the reaction. That plus that gives you that product. And we know that that's going to happen this way. So I will have a nucleophilic attack over to my electrophile, and I get that product. So that's one possible way to synthesize that molecule. And we're going to try another disconnection now. Let's say that instead of breaking that there, I'm breaking it here. Now, again, the fragment that has the oxygen will be an aldehyde. The other fragment is going to be my Grignard. And I'm going to do the arrow this way because, again, I'm thinking backwards. And this fragment is now my Grignard. And so here I'm going to do magnesium bromide. Again, my rings is not coming that great. Let me do that one more time. Okay, so that's the Grignard fragment, and the other fragment would be the aldehyde. So you make an aldehyde at that point, and it's that. I'm just trying to draw it similar to that so you can see this how it's done. Okay, so, and you can always check that. Remember that this goes, the polarity here will be plus, minus here, and then you will do the nucleophilic attack. So that attack over here will give you the alkoxide, which later so first step will be that, and remember that afterwards you need to add water to protonate the alkoxide that you're forming. So so you here will form the alkoxide. And you need to add water so that you form the alcohol that you want. But when you're disconnecting again, these are two ways. You get this aldehyde is one possibility, and then you have the other. Now say that the problem wants you to determine what option will give you a better yield. Now here, we want to remember how we make the Grignard. To make the Grignard here, you need to start from an alkyl halide, and that is secondary. And the other reaction, no, I'm going to cut that.